Welcome to our comprehensive guide on Android DSA questions for interviews. Whether you're preparing for your first Android developer interview or aiming for a senior position, understanding data structures and algorithms is crucial. In this video, we'll walk through real-world scenarios and solutions that are commonly asked in interviews. We'll cover everything from optimizing app startup times to detecting cycles in user session data. By the end, you'll have a solid grasp of how to approach these questions and demonstrate your expertise. Let's dive in and start building your confidence for your next interview. Interviewers often use puzzle-type questions to assess your analytical thinking and programming knowledge. These questions are especially important for senior Android roles, as they test your ability to solve complex problems efficiently. In this section, we'll introduce the types of puzzles you might encounter, such as optimizing app startup, efficient caching, and finding duplicates. By understanding the logic behind these puzzles, you can approach them with confidence and clarity. Let's explore how to break down these challenges and apply the right data structures and algorithms for each scenario. One common interview scenario involves optimizing an app startup time. Imagine your app fetches a configuration file with key value pairs that are accessed frequently during runtime. The goal is to load the configuration quickly and retrieve any value in O1 time. The best solution here is to use a hash map, which allows for constant time lookups. By iterating through the configuration list and storing each pair in a hash map, you ensure fast access throughout the app's lifecycle. This approach not only improves performance but also demonstrates your understanding of efficient data structures. Caching is vital for Android apps, especially those dealing with frequently accessed content like news articles. Interviewers may ask how you design a caching mechanism to store articles and retrieve the most recently accessed item quickly. The ideal solution is an LRU cache, least recently used, which can be implemented using linked hash map in Kotlin. This structure automatically removes the least recently used items when the cache exceeds its capacity, ensuring that the most relevant data is always available. Understanding and implementing LRU caching shows your ability to manage memory and optimize user experience. Gallery apps often need to identify duplicate images to help users manage storage. The interview question here is how to find duplicates when each image has a unique hash. The solution is to use a set to track hashes as you iterate through the list. If a hash is already in the set, it's a duplicate. This approach is efficient and leverages the properties of sets for quick lookups. By applying this method, you can easily detect and handle duplicate images, showcasing your practical problem-solving skills in real app scenarios. Scheduling notifications without overlap is a common requirement in reminder apps. Interviewers may ask you to write an algorithm that checks if reminders can be scheduled without conflict. The solution involves sorting reminders by start time and checking for overlaps using intervals. By iterating through the sorted list and comparing start and end times, you can detect conflicts efficiently. This technique demonstrates your ability to handle time-based data and ensure smooth user experiences in apps that rely on timely notifications. Displaying large datasets in Recycler View requires efficient data loading to avoid performance issues. Interviewers might ask how you'd fetch only the required data for display. The best approach is pagination, which loads data in chunks using Android's paging library. By implementing a page list adapter and fetching data page by page, you minimize memory usage and improve responsiveness. This method is essential for apps with infinite scrolling or large lists, and it highlights your understanding of scalable UI patterns in Android development. Merging sorted lists is a classic interview problem, often encountered when dealing with user data from multiple sources. The question is how to merge two sorted lists into one sorted list efficiently. The two-pointer technique is the optimal solution, allowing you to iterate through both lists and combine them in order. This approach ensures that the merged list remains sorted and minimizes computational overhead. Mastering this technique is valuable for handling data synchronization and aggregation tasks in Android apps. Detecting missing data is crucial for maintaining data integrity in apps. Interviewers may ask you to find a missing user ID in a sequential list. The sum formula for the first and natural numbers provides a simple yet effective solution. By calculating the expected sum and subtracting the actual sum of IDs, you can pinpoint the missing value. This method is fast and demonstrates your ability to apply mathematical reasoning to solve practical problems in app development. User session data and linked lists can sometimes form cycles, leading to infinite loops or memory leaks. Interviewers often ask how to detect such cycles. Floyd's cycle detection algorithm, also known as the fast and slow pointer method, is the standard solution. By moving two pointers at different speeds, you can identify cycles efficiently. This technique is fundamental for ensuring robust data structures and preventing issues in session management. App and network requests, such as those from a search bar, can overload servers and degrade performance. Interviewers may ask how to demonstrate these requests, ensuring only the final input is processed after a delay. Using Kotlin coroutines or handler, you can implement demonstrating by canceling previous jobs and executing the search after a set delay. This approach optimizes network usage and enhances user experience, especially in apps with real-time search functionality. Performance metrics often require identifying the KTH largest value for analytics. The interview question is how to do this efficiently. Using a min heap, you can maintain the top K elements and retrieve the KTH largest quickly. This method is scalable and suitable for large datasets, making it ideal for performance monitoring and reporting in Android apps. Validating user input, such as checking for palindromes, is a common interview task. The solution involves sanitizing the string, revering it, and comparing it to the original. This simple yet effective approach ensures accurate validation and demonstrates your attention to detail in handling user data. Understanding which app features are most used can guide development priorities. Interviewers may ask how to find the top K frequent features. Using a hash map for counting and a priority queue for sorting, you can efficiently identify the most popular features. This technique is valuable for analytics and feature optimization in Android apps. Tracking user activity over time can reveal engagement patterns. The interview question is how to find the longest consecutive sequence of activity timestamps. Using a hash set for quick lookups, you can efficiently identify and count consecutive sequences. This approach is useful for analyzing user behavior and improving app engagement strategies. Apps often need to track the number of users active at the same time. Interviewers may ask how to calculate the maximum concurrent users given login and logout times. Using sorting and a sweepline technique, you can process events efficiently and determine peak usage. This method is essential for scaling infrastructure and ensuring smooth operation during high traffic. Avoiding repetition in app screens enhances user experience. The interview question is how to rearrange screens so that no two adjacent screens are the same. Using a max heap priority queue, you can organize screens by frequency and place them optimally. This technique demonstrates your ability to manage UI flow and prevent redundancy. Counting unique users is fundamental for app analytics. Interviewers may ask how to count unique user IDs in a list with duplicates. Using a hash set, you can store unique IDs and determine the count efficiently. This approach is straightforward and highlights your understanding of set operations in data analysis. Navigating between app features can be modeled as a graph. The interview question is how to find the shortest path between two features. Using breadth-first search (BFS), you can traverse the graph and calculate the shortest distance. This method is essential for optimizing navigation and improving user flow in complex apps. Rotating app content such as carousel items is a common UI requirement. Interviewers may ask how to rotate a list by K positions. Using modular arithmetic and slicing, you can shift content efficiently. This technique is useful for implementing dynamic UI elements and keeping content fresh for users. Testing all possible combinations of app menu items ensures comprehensive coverage. Interviewers may ask how to generate these combinations. Using backtracking, you can systematically explore all subsets of menu items. This approach is valuable for testing, feature exploration, and ensuring robust app functionality. Identifying anomalous app usage patterns helps maintain app health and user safety. Interviewers may ask how to detect users exceeding a usage threshold. Using a hash map to aggregate durations and compare against the threshold, you can flag anomalies efficiently. This method is crucial for monitoring and managing user behavior. Feature dependencies in apps can sometimes form cycles, leading to maintenance challenges. Interviewers may ask how to detect circular dependencies in a graph. Using depth-first search (DFS) with a visited set, you can identify cycles efficiently. This approach ensures clean architecture and prevents issues in feature integration. Android DSA interview questions test your ability to solve real-world app development problems efficiently. By combining data structure knowledge with Android-specific scenarios, you can demonstrate your expertise and readiness for challenging roles. Practicing these types of questions builds confidence and prepares you for success in interviews. Remember, the key is to understand the problem, choose the right data structure or algorithm, and explain your reasoning clearly. Let's continue to explore more advanced topics and deepen your understanding. Beyond technical skills, networking with other Android developers can accelerate your growth. Join professional groups, participate in discussions, and share your interview experiences. Platforms like LinkedIn, GitHub, Instagram, and WhatsApp offer opportunities to connect with over 900 Android developers. Being part of a thriving community helps you stay updated, learn from others, and level up your career. Let's see how community engagement can support your journey. Designing scalable Android app architecture is a frequent interview topic. Interviewers may ask how you'd structure an app for maintainability and growth. Key concepts include modularization, separation of concerns, and using frameworks like Jetpack Compose and Kotlin multi-platform. By demonstrating your architectural knowledge, you show readiness for leadership roles in complex projects. Synchronous programming is essential in modern Android development. Interviewers may ask about Kotlin coroutines and their role in keeping apps responsive. Understanding coroutine scopes, dispatchers, and structured concurrency is vital. By mastering these concepts, you can build apps that handle background tasks efficiently and provide smooth user experiences. System design questions assess your ability to build robust and scalable Android apps. Topics include designing for scalability, reliability, and maintainability. Interviewers may ask about handling large user bases, optimizing performance, and integrating third-party services. Preparing for these questions ensures you're ready for advanced roles and complex projects. A well-optimized resume increases your chances of landing interviews. Interviewers look for clear, concise descriptions of your skills and achievements. Highlight your experience with Android, Kotlin, Jetpack Compose, and DSA. Tailor your resume for each role, focusing on relevant projects and outcomes. This strategy helps you stand out and attract recruiters. Choosing the right networking solution is crucial for Android apps. Interviewers may ask about the differences between retrofit and KTOR. Retrofit is widely used for REST APIs, while KTOR offers flexibility for custom protocols. Understanding their strengths helps you select the best tool for your project and explain your choices in interviews. Delivering Android apps in the right format is essential for user experience and distribution. Interviewers may ask about the differences between APK and AAB. APK is the traditional format, while AAB Android App Bundle is recommended for modern apps, enabling optimized delivery and smaller downloads. Understanding these formats demonstrates your knowledge of app deployment best practices. Modeling view model state is key for clean, scalable Android architecture. Interviewers may ask how you manage state transitions and handle UI updates. Using immutable data classes and state flows ensures predictable behavior and easier testing. This approach is vital for building maintainable apps and demonstrates your architectural skills. Clean architecture ensures your Android apps are maintainable and testable. Interviewers may ask about flow-based approaches and separation of concerns. By structuring your app into layers, presentation, domain, and data, you can achieve modularity and scalability. This knowledge is essential for advanced development roles. Staying productive as an Android developer requires effective tools and strategies. Interviewers may ask about your workflow and how you manage tasks. Using tools like task lists, version control, and automated testing helps streamline development. Sharing productivity tips demonstrates your commitment to continuous improvement. Natural language processing (NLP) is increasingly relevant in Android apps, from chatbots to voice assistants. Interviewers may ask about your experience with NLP libraries and integrating them into apps. Understanding tokenization, sentiment analysis, and language models can set you apart in interviews for innovative projects. Exploring staff picks and recommended articles on platforms like Medium can expand your knowledge. Interviewers appreciate candidates who stay updated with industry trends and best practices. Reading and sharing insights from top articles demonstrates your passion for learning and professional growth. Organizing your learning resources into lists helps you track progress and revisit important topics. Interviewers may ask how you stay organized and manage ongoing education. Using lists for coding questions, architecture patterns, and productivity tips ensures you're always prepared for interviews and new challenges. Continuous learning is essential for Android developers. Interviewers value candidates who invest in ongoing education, attend workshops, and participate in online courses. Staying updated with the latest frameworks, libraries, and best practices ensures you remain competitive and ready for new opportunities. Sharing your interview experiences with the community helps others prepare and learn from real scenarios. Interviewers appreciate candidates who contribute to knowledge sharing and support peers. Writing articles, participating in forums, and mentoring others builds your reputation and strengthens your network. Confidence is key to succeeding in Android interviews. Practicing DSA questions, reviewing architecture patterns, and engaging with the community builds your self-assurance. Interviewers notice candidates who approach problems calmly and explain their reasoning clearly. Keep practicing and stay positive. Thank you for joining us on this journey through Android DSA interview questions and answers. We hope this guide helps you prepare effectively and boost your confidence for upcoming interviews. Remember, practice and continuous learning are your best tools for success. Stay connected with the community and keep striving for excellence. If you need help related to Android or Kotlin, Anand Gower is always happy to assist. Follow him on LinkedIn, GitHub, Instagram, and WhatsApp to stay updated with the latest articles and tips. Connecting with experienced professionals accelerates your learning and opens doors to new opportunities. Joining Android developer groups is a great way to network, share knowledge, and stay motivated. Over 900 developers have already joined Anand Gower's professional group. Being part of such communities helps you level up your career and stay ahead in the industry. Explore more articles and resources from Anand Gower and other top Android developers. Reading about coding questions, system design, and productivity tips keeps you informed and inspired. Make learning a habit and continue growing as a developer. Preparing for Android interviews can be challenging, but with the right strategies and resources, you can succeed. Focus on mastering DSA concepts, practicing real-world scenarios, and engaging with the developer community. Stay curious, keep learning, and approach each interview as an opportunity to showcase your skills. Good luck on your journey.